find the derivative of z equals x squared minus y squared at the point 1, 2 in the direction of the vector v equals 1, minus 1. So I'm finding a directional derivative at the point p naught in some direction u, which that's not u, right? That's not a unit vector. I'll have to calculate that. The only tool I have right now is to use the definition of the directional derivative. So I need to evaluate this limit. So I need to evaluate my function in two different places. At x naught plus delta s u1 and at x naught plus delta s u1, comma y naught plus delta s u2 and at x naught y naught. So we'll come back to this limit statement, but let's see if we can figure out what all this stuff is first. So the point p naught is 1, 2. And my vector u, I need to be a unit vector that has the same direction as this vector. Well, this vector has length square root of 2. So my unit vector u would be the vector 1 over root 2, minus 1 over root 2. And you can rationalize your denominators if you prefer, but I'm going to leave it just like that. So I need to evaluate f of x naught plus 1 over root 2 delta s, 2 plus minus 1 over root 2 delta s. And I also need to evaluate f of 1, 2. Well, let's do this part first. So my function z equals x squared minus y squared. So 1 minus 4 is minus 3. And then this one's going to take just a little more work. Maybe it would be beneficial to remind us what the function is here. So I need to square this part. So let's see, that's going to give me 1 plus root 2 delta s plus 1/2 delta s squared minus what I get when I square the y. So let's see, that's going to be minus 4. Well, let's see, if I just multiply those together, I'll get minus root 2, so I need to double that. Minus 2 root 2 plus 1/2 delta s squared. Let's go on and simplify this. So let's see, I have 1 minus 4 is minus 3. I have root 2 delta s plus 2 root 2, and I left out a delta s there. So root 2 delta s plus 2 root 2, so plus 3 root 2 delta s. And then I have a 1/2 delta s squared minus a 1/2 delta s squared, so I'm done. That's my final result. So on the top of my fraction, I'll have this minus this. So I'm going to go and write that down on my other board off camera. And it will just seem that it appeared on the board. And there I have it. Because we did this work on that other board, and look, minus 3 minus a minus 3, those cancel. And let's see, I have 3 root 2 over delta s, I have 3 root 2, and so my derivative apparently is 3 times the square root of 2.